Okay, maybe I can start. And it is sad for me to give this commemorative recognition of Paolo, but this is something that we have to do because Paolo has had an important role in my life, in the life of his former students. And just to summarize, who was Paolo? Now, Paolo was a theoretical physicist who dedicated his life to unravel mechanisms underlying brain functions. Just after master in science, in physics, at the end of the 80s, Paolo continued the study of neural networks in a period of which many of the leading physicists, not only in Rome, started to exploit the similarities of magnetic and optical networks. In this context, we published several papers together with Miguel Tesoro, with Varga, with Nadal, and France. And it was the beginning of the 90s when he got a position at the physics laboratory of the Instituto Superiore di Sanità, Rome, where he worked for the rest of his life, and where he served for several years as a also of the scientific community, scientific board. Paolo was always fascinated by the enrichment resulting from the contamination between different scientific fields. He was one of the first to use neural networks and energy physics to detect specific events resulting from particle collisions. In line with this, Paolo, in cooperation with several groups in Rome, including the one led by Hamid, my supervisor at the time, and created one of the very first homomorphic systems capable to learn attract, which is in this picture. 20 years ago, Paolo started our journey to study the population dynamics of spiking neural networks, relying on extended main field, as Daniel called theory, and developing one of the first event-driven simulations. Interaction and scientific exchanges with other was for Paolo a priority, leading to establish many collaborations that naturally turn into research projects where deep relationship or friendships rise. Paolo loved to teach, and he was an inspiring lecturer of neural networks in Rome. Many students have been contaminated by his passionate approach to science and becoming themselves scientists. And just to continue this commemoration, I will leave the show to Guido Gigante, one of his former PhD students, that will tell you more about the recent activity.
Yeah, I had the pleasure to work with Paolo for almost 20 years. And it's been really an exhilarating time. And Paolo, for me, has been much more than a mentor, a senior colleague, much more. But that's not me to be personal. So today, I don't want to present you with a list of works and accomplishments. And but I want to try to convey the flavor of doing science with Paolo during these years. First of all, I want to underline the most striking feature of Paolo's scientific legacy, that is diversity. Paolo touched so many fields and issues. Just two examples, one dating back more than 10 years ago, and the other one was something that we were still working on. The first was a model of a model we built to explain many experimental findings in vestibular perception as a stochastic integration of information at two levels. The second was an attempt to infer probabilistically the trajectory of a Hodgkin and Huxley neural model in a reduced parameter space just by observing the shape of its spikes. And so you see different experimental contexts, different scales, and different methodologies. Paolo, was a man of infinite curiosity, and there was hardly any scientific question that could not spark his interest. And this clearly speaks in favor of such diversity, but at the same time, it wasn't just that for me. Paolo, as also Maurizio mentioned, was oh, unfortunately there is a video, but okay, it's showing. Paolo was an inspiring teacher capable of balancing intellectual freedom with wise guidance. And part of this diversity comes just from this, from letting the students to grow by being free to explore. For example, the Ocean-Axis model, inference model that we saw before, was the result of a master thesis of a brilliant student of his. And I think there's another final aspect in this diversity. Paolo liked to call himself a craftsman of science. And this was foremost a statement of humility in front of the complexity of the world. But at the same time, I think it was also some sort of a methodological manifesto for him. He, as like all the best artisans, liked to build tools and try them on different materials. For example, in analyzing multi-channel data in the context of inhibition of a planned movement, Paolo developed with his collaborators a new clustering technique inspired by a landscape view in the space of data points. Yet diversity in the case of Paolo was not synonymous with superficiality, not at all. Paolo was definitely a theoretical physicist, and as such, he liked to pose very deep questions. And even as he searched for answers in very different domains, I think that a coherence clearly emerged in his work. Probably the most prominent theme for Paolo in recent years has been the role of multiple scales, be them temporal or spatial or functional, both from a theoretical perspective and in analyzing experimental data. We have already seen the two functional levels in modeling vestible perception, and clustering for Paolo was just not a technique to explore data, but also a tool to uncover discrete collective states emerging from the microscopic cortical dynamics. We can add to that a mean-field model to explain the unfolding over multiple time and space scales of up and down states and neuronal avalanches. And finally, we were just completing this work, the role of multiple time scales in a perceptual decision-making task. So another very different experimental setting, but really the same question. But that's not all. I admire Paolo for his incredible openness to new ideas, and at the same time, his ability to twist them to answer these questions. And in this decade, there has been sort of a revolution in machine learning, and Paolo didn't shy away from this challenge. Paolo leveraged the new technologies that have been developed in machine learning to let data constrain models to an unprecedented degree. So the mean-field model, we mentioned that before, a few years later has morphed in an attempt to infer the entire structure of a spiking network directly from highly non-stationary data. We also tackled the question inside this inference framework of the effect of introducing many different synaptic delays in a network. Again, the role of multiple timescales, but with a very different flavor. And for the perceptual decision model, he brushed up his knowledge of reinforcement learning in the view of the many recent developments in the field. And very recently, he also supervised a master thesis that applied a deep convolutional neural network to multi-unit activity recordings for the prediction of a behavioral outcome. So, and in what I believe has been his very last paper, he tested a new learning algorithm for acoustic networks you can guess it, a multi-level stochastic inference problem. And so you see many things, and now recalling them, it really feels like, for me, like having been on a roller coaster, a lot of excitement and many happy moments. And so I think this is that we want with Maurizio and the other collaborators to remember Paolo. The wonderment in his eyes for discovery, and joyfully lost in his restless pursuit of knowledge for the benefit of humankind. Thank you very much.
Thank you very much. I thank Maurizio and the other colleague for these nice memories of Paolo Del Giudice. And I think that the best way to commemorate